Hello students, in the previous lecture we had discussed the multi-quadrant operation, the various modes of operation of the drive, that is forward motoring, forward braking, reverse motoring, reverse braking. So these we discussed in the previous lecture, but now I will explain these four modes of operation with the help of one example. Example I have taken is the example of a lift or a hoist. A lift consists of a drum over which some belt or some rope is wound. On one side of the rope, the cage is there in which the persons or the goods are to be moved, and on the other side we have a counterweight. It is so designed that the counterweight, that is WCW, is less than the weight of the loaded cage, and the counterweight is more than the empty cage. So what will be the forces acting here? The one force is acting here because of the cage, that is mass of the cage multiplied by the acceleration due to gravity. So this force is acting downward, and there is a force because of counterweight, that is MCW multiplied by G. Again it depends on the gravity. So this force exerts a clockwise torque, whereas the counterweight exerts an anti-clockwise torque. So what is the total torque? That will be equal to WCW, that is weight of counterweight minus weight of cage multiplied by the radius of this pulley or the drum. So depending on the value of WC, the load torque can be positive or it can be negative. So here I have shown that the load torque is in the counterclockwise direction when this cage is empty. When the cage is empty, the weight of counterweight is more, so this torque is higher, so the net load torque is acting against in the counterclockwise direction. And the motor that is coupled to this drum or pulley, it has to exert a torque in the clockwise direction to overcome this load torque. I have shown this in the bold lines here. On the other hand, if the cage is loaded such that the weight of the cage is more than the weight of the counterweight, in that case this clockwise torque will be more, so the net load torque will be in the clockwise direction, and the motor has to produce a torque in the opposite direction. So this is one example, and in various situations we have to operate in first quadrant, second quadrant, third quadrant or fourth quadrant of speed torque plane. So this I will just explain. Now here I have drawn these diagrams, speed versus torque, and let us discuss the first quadrant operation, that is the forward motoring mode. As we discussed in the previous lecture, that we have taken a convention that anti-clockwise direction I have taken as positive. So it is the first quadrant operation, speed is positive, so the speed is in this direction. And it is forward motoring operation. This means that the motor has to move the system, move the cage. This means that the motor has to exert a torque in the direction of speed. Now here you can see that I have shown that the cage is loaded cage. Some persons are there in this cage. So the net load torque, because weight of this cage is more than the counterweight, the load torque is acting in the clockwise direction. So if you don't apply any torque from the motor, the cage will move downward by itself and its speed will go on increasing because there is no counter torque acting against it. So the cage will go on moving downward with increasing speed if you don't connect any motor to it. But the motor is connected and the motor will overcome this load torque and produce some extra torque so that the cage starts moving in the upward direction. So this is what is known as forward motoring operation. If the motor connected with a DC motor, then you have to maintain this type of situation that applied voltage is more than the back EMF, so that the current flows in this direction, positive direction. The energy is released from the source and absorbed by the system, by the motor, and the motor produces mechanical energy required to move the cage in the upward direction. So that is forward motoring operation. Now suppose again we come to the second mode of operation, that is forward braking mode. When it will be required? The cage is empty cage and the counterweight is there, which is more than the weight of this empty cage. So the load torque will be acting in counterclockwise direction, because this is higher than this. So load torque is in the counterclockwise direction. If you don't connect any motor, what will happen? Because of this counterweight or clockwise torque, anti-clockwise torque, the cage will move upward with increasing speed. You have to move the cage at a constant and comfortable speed, at a safe speed. So we have to counter this load torque such that the speed is maintained at a constant value. It does not become very high. So we have to produce a torque in the opposite direction. So motor will produce a torque in the clockwise direction to overcome this load torque, so that, or torque which is nearly equal to the load torque, so that the cage moves slowly in the upward direction. If you don't apply any torque here, the cage will move at a very high speed. The speed will go on increasing because there is no opposing torque acting against it. So what you have to do here, same motor is connected here, but if you want to move it upward, you have to maintain voltage less than the back EMF. Now you can see that in this case the load torque is moving the system. So load torque is moving the system and the motor is working as a generator. So you can see here you have to make V less than E such that the current flows in the opposite direction, so that the torque is opposite to what it was in the forward motoring mode. So this is the forward braking mode. So load drives the system. Load drives the motor. In the case of motoring mode, motor drives the load. So these are the first two modes. In the reverse mode, let us discuss the third quadrant operation here. So it is reverse motoring mode. Third quadrant means speed is negative and torque is also negative. So we are in the third quadrant of speed torque plane. As the speed is negative, I have shown here the direction of speed is opposite to what it was for the first and second quadrants. So speed is clockwise direction. Now we have to think whether the cage should be empty or loaded. For this, you can see that I have shown here the cage is empty cage, so that the load torque is in this direction. Load torque is in counterclockwise direction, and we have to move the motor in the clockwise direction. This means that we have to apply a torque from the motor in the clockwise direction. So this means that the motor torque is driving the load. So torque and speed are in the same direction, and the load torque is in the opposite direction. So this is what is known as reverse motoring mode. That is, if you have to lower the cage, empty cage downward, then you have to produce a motoring torque in the reverse direction. In the case if we are using DC motor here, then what we have to do, we have to move the lift in the downward direction. This means that the speed has to be opposite to what it was in the previous cases. So the voltage has to be reversed. Voltage is negative here. Earlier it was positive in both cases. So it is now negative. And for motoring operation, V should be more than E, so that the current flows here. Current leaves the positive terminal of the source and enters into the positive terminals of the back EMF. So we have to make V more than E, so that current flows in this direction, and this current produces a torque, and the motor moves in the direction of torque, that is in the clockwise direction. So this is what is known as reverse motoring operation. And finally, the reverse braking or fourth quadrant operation. If speed is negative, torque is positive. So we are in the fourth quadrant. It is reverse braking operation. Here the cage is loaded, and we have to move the cage downwards. So speed has to be in the clockwise direction, and the load torque is in the counterclockwise direction, because the load torque is in clockwise direction because it is a loaded cage. The weight of this cage is more than the counterweight, so the load torque is in the direction of the desired speed. So the load torque will drive the cage, whereas we have to produce a counter torque from the motor, so that the speed of the cage is maintained within safe limit at the desired speed. So we have to maintain such a value of torque here, so that the cage moves at a safe speed. So again, what you have to do here, because it is a braking operation, the load is actually moving the motor. Load is actually moving the system. So we have to produce a torque in the opposite direction. So you can see here what we have done here. The voltage has been reduced below the value of back EMF, so that the current flows in this direction. The energy is released from the system and absorbed by the power source. So this is what is the reverse braking operation. So this example explains the situation where we may require four quadrant operation. So if you have to operate a lift, then you need a drive which will be a four quadrant or multi-quadrant drive. So this is the multi-quadrant operation. Now here I have shown one case of lift. As you can see here, the load torque which is acting here is some weight which is constant multiplied by R. So this load torque is independent of speed. What will be the speed? The load torque will remain constant. Load torque is constant, it doesn't depend on speed. Such a load is known as constant torque loads. You will see some other loads in the next lecture. There are various types of loads. Some loads are constant torque load. Some loads are speed dependent loads. Some loads depends on square of the speed. Some loads decrease with the load with the speed. So various types of loads are there, and we have to accordingly choose the motor and design your system so that the load characteristics matches with the motor characteristics. So this is all for today. Thank you very much.